Graphing the cosine function. To graph any function that's a trigonometric function, we're interested in maybe four things: the shape of the function, the range of the particular function. We would want to know what domain we're graphing it in, and we'd want to know what the period of this function would look like. So in cosine of x, the answers to these are maybe fairly straightforward. So the shape of this function is a cos function. So a positive cos function begins at a high point for x equals 0 and repeats itself every 360 degrees, every 2 pi. At 90 degrees it's at its minimum and it's back to its maximum at 360 again. The range of this function is between -1 and 1, because this is just cos x, not twice cos x or 3 times cos x. The domain of this function is, we're given in this question, we're asked to graph it between -360 and +360. And the period of this is just a normal 360 because the angle here is x. It's not 2x or a half x or 3x. So let's graph this then. We know its high points, its low points. We know where it crosses the x-axis. So this is one period of the wave, looks like this. And we do the same in the negative direction. So we should be able to draw this reasonably accurately, at least going through some of these major points. So this is what the graph of cos x looks like. We'll be then asked to show that on this graph there are 4 different angles that satisfy the equation cos x is equal to a half. So if I measure out where y is equal to a half, I can see, yes, there are 4 different points on the curve that this line goes through. So I can see that there are 4 different inputs that will give that output. We're not being asked in this question to work out what those 4 angles are, but I think it's a reasonable thing that you could be asked. So let's continue with this question here. You might realize that cos of 60 is a half. If you didn't, you could write cos inverse of a half and it tells you 60. By symmetry, looking at this, we could work out then what the other 4 points are by adding 60s or subtracting 60 to different places. So we see 300, 60, -60, and -300 are the other, are all the 4 points in the curve to give this. If you want to do this in a more accurate way, to be sure of it, you could use a calculator. Like you could input those things, cos of those angles, the calculator, and see that the answer is a half. Or you could input the function. So you could have started the question this way. Write down f of x is equal to cos x. That's the function. We want to start our domain at -360. And we're going to end at 360. And we will go up in steps of 60. Now there's a bit of inside knowledge here because we can see from a graph that we'll probably find all the points we're looking for if we go up in steps of 60. And now if you look at this, it'll give us the input-output points. And again, we can see from this which angles are giving outputs of a half. So we can see that our 4 answers are correct. So this would be another way of maybe graphing the function as well, using the calculator table function.